Right, so there's a question mark here on the title because I think there's still real uncertainty about whether the AI systems that we're experiencing are having thoughts or not. So when we think about what AI is, right, it's obviously about making intelligent machines. And for most of the history of the field, it's been about machines that whose actions can be expected to achieve their objectives. This is a definition borrowed from economics and philosophy, the idea of rational behavior. And that's dominated AI since the beginning. And there's lots of different ways to do that, search, problem solving, reinforcement learning, and so on. But this is essentially all the techniques that we have. And the most recent systems are trying to do this simply by copying human behavior, which keeps the objectives implicit. And the goal, if you go back and look at what the founding fathers of the field wrote, it's pretty clear that the goal is general purpose AI. So AI systems that can do anything human beings can do, can learn to do it very quickly, and will probably exceed human capacities along pretty much all relevant dimensions once this becomes possible. The question that you might ask, this is a question we've had in our textbook since the first edition, 1994, is what if we succeed in this goal? And it seems sensible to ask, because we are now pumping hundreds of billions of dollars into precisely this goal. So what happens if we get to this destination that we are all aiming for? And I think the hope is that we could have a much better civilization, as Corinne illustrated with her examples, because our civilization is made of intelligence. And we got more intelligence, we could have a better civilization. Stands to reason. And just as a lower bound, right, if you have general purpose AI and its physical extensions in the form of robots, then it can do all the work, all the things that we already know how to do. And we know how to deliver a very nice standard of living to a lot of people on Earth. Maybe close to 1 billion have what the French would call a good standard of living. And maybe they set the standard for that. But of course, it's not available to everybody on Earth. But with AI, we can deliver it at very low cost on a much bigger scale. So we could do this for everyone on Earth, subject to the political and economic considerations that Laurent mentioned was one of his big concerns. And if you calculate the net present value of that, since we are OECD, you all know what net present value means, right? So it's the cash equivalent of that increased income stream. It's about $13.5 quadrillion. So that's a lower bound on the cash value of general purpose AI as a technology. So when you see that, there are billions of dollars being invested, I think it's about 10 billion a month being invested into specifically AGI startups, right? So not applied AI startups, these are AGI startups whose goal is to create AGI, 10 billion a month. That's a minuscule amount, right? So I guess it says something about how difficult we think the problem is and what the chances of success are in the near term. But we could have much better civilization, right? Not just replicate what we have at scale, but actually deliver much better healthcare to people, individualized education of a very high quality for every child on Earth, rapid advances in science and medicine and so on. So all of that would be great. So this is what we are looking for in the upside. And some people think we're already there, right? That in fact, AGI or something like AGI, something like general purpose AI is here. I don't think we're that close. I would say most people feel it's a lot closer than they would have guessed 5 years ago. And there are more recent surveys, and they've been done at fairly close intervals over the last decade. and the median seems to be getting closer rather than farther away. And with nuclear fusion, it's always getting further away, but with general purpose AI, it seems to be getting closer, so that's interesting. And I would say that the large language models of what everyone's talking about now, I think they are a piece of the puzzle. They are not the solution, and scaling them up is not the answer. And in fact, just last week, Sam Altman of OpenAI said, scaling them up is not the answer. We're not planning to make GPT-5, and we need different techniques because this doesn't work. So that's a very interesting point. At the moment, we don't even know what shape this puzzle piece is, right? We don't know what's printed on it to make the jigsaw, and we don't know what shape it is, so we don't really know what other pieces we need or where to fit it in. And these are basic research questions that we still have to answer. On the other hand, you've got Microsoft, this actually very distinguished group of scientists, including 2 members of the national academies in the US, who spent several months working with GPT-4, and this is their conclusion, that it shows sparks of AGI. So you may disagree with that, but I don't think you can just completely discount it as being irrelevant, because these people have more experience with GPT-4 than pretty much any other human being on Earth. So we have to at least listen to what they have to say. Now, of course, you all know, right, and all your friends send you examples of this. It's my friend Prasad Tadapalli who sent me these examples, which is bigger, an elephant or a cat? An elephant is bigger than a cat. Very good. Which is not bigger than the other, an elephant or a cat? Neither an elephant nor a cat is bigger than the other. Okay, so it's not so much that it made a silly mistake, it's that it contradicts itself on a basic fact, right? And this points to the question, does it know anything at all? Right? So knowing and being able to answer a question correctly are not the same thing. Right? Knowing means that you understand that what you know is consistent or inconsistent with something else, that you can draw conclusions from that. And I think there's plenty of evidence that the large language models are not building internal models of the world and answering questions with respect to that model, and they are rife with inconsistency as a result, which I think is actually giving up on an enormous source of power, right? Because taking all the evidence from everything the human race has ever written and building a logically consistent internal model would be far more effective than what the current systems are able to do. So another part of the problem with not just large language models, but deep learning in general, is that it's based on circuits. And any computer scientist knows that circuits, while they're useful, are a terrible language for representing almost anything you want to write down. And we haven't used circuits for computing since before World War II. Right? As soon as we had general purpose programming languages, we stopped wiring up circuits to do computing, and we started writing programs instead. And we had this idea that actually even the superhuman Go programs had not learned the basic definitions you need to play Go. What is a group? Is a group alive or dead? Those are the things you need to play Go at all. And so we actually started doing some experiments. And I'm just going to show you a game of Go between one of our group members, Kellen, who's a pretty good amateur Go player. His rating's about 2,300. And as you all know, Go programs have defeated all human world champions and national champions. And that was 6 years ago that they beat the human world champion, whose rating is around 3,800. They're now rated around 5,200, so they are massively superhuman. And so here we have a player rated 2,300. He's going to play a massively superhuman Go program rated 5,200, and he's going to give that program a 9-stone handicap, right? Which is the kind of handicap you give to a baby. When you're teaching a baby, a little tiny kid to play Go, you give them 9 stones to start out with, right? And it's that's just being very, very nice. Okay, so here goes the game, and the computer is playing black, and the human Kellen is playing white. And so what happens in Go is you try to surround territory, and you just try to surround your opponent's pieces and capture those pieces. So Kellen is building a little white group, sort of in the middle, slightly to the bottom right, and then black very quickly surrounds that group and is trying to kill it. And then white is now surrounding the black group, so it's making a kind of circular sandwich. And black completely ignores this. It doesn't understand that those pieces are going to be captured. And then white just captures all the pieces, and that's the end of the game. So the superhuman Go program doesn't understand the most basic concepts of Go. And so when we say the OECD principles, AI systems need to be robust and predictable, they are nothing like robust and predictable. Okay, so someone else who asked what happens if we succeed was Alan Turing. And he was actually asked this question, what if we succeed, in 1951 at a lecture. And this is what he said. It seems probable that once the machine thinking method had started, it would not take long to outstrip our feeble powers. At some stage, therefore, we should have to expect the machines to take control. So that's what I've been working on for the last decade, is he right? And how do we avoid it? So I prefer to ask this in the form of a question rather than a prediction. We're going to make systems that are more powerful than us. How do we retain power over entities more powerful than us forever? Right? That's the question we need to ask. And I think that's the underlying question of the open letter. Right? The open letter is not targeting existing systems. It's not targeting research and development. It's just saying, at some point this is going to happen. We need to be prepared ahead of time and have solutions and regulations in place. Right? We are building a planetary defense system against asteroids. Nobody suggests that we should only build that after the asteroid has destroyed the Earth. Right? That would be silly. But many people are saying we should only regulate general purpose AI, AGI, artificial superintelligence, after it arrives. Because before it arrives, we won't know what to do. Right? And I think that's equally silly. So one answer to the question, how do we retain power, is actually to get rid of the standard model for AI. So this was the standard model. Machines are intelligent to the extent their actions can be expected to achieve their objectives. And this is exactly the source of the problem. Because to use AI systems of this type, we need to specify the objectives. And as everybody knows, going back to King Midas and before, we cannot specify objectives correctly because we can't write down what it is that the human race wants the future to be like. And as you build AI systems that can affect what that future is going to be, then you really face a problem. If you get it wrong, you're setting up a chess match, and at least the chess programs, we haven't figured out how to beat them yet. So we get rid of this idea, and instead we want AI systems that are beneficial to us, right? And beneficial means that their actions actually achieve our objectives. And that sounds counterintuitive, right? How can you build systems that achieve our objectives when our objectives are in us and not in the machine? But it turns out that there's a mathematical framework that's perfectly straightforward that does yield systems with this property. And you basically, here's the constitution. The systems have to act in the best interests of humans, and they don't know what those best interests are. And they know that they don't know what those best interests are. And this creates a different type of AI system that is potentially provably beneficial to humans. And you can turn it into this not just a constitution, it's actually a mathematical framework called an assistance game. And we'll actually talk about assistance in the scenario discussion. So we'll get to see how these ideas play out in practice. And when you solve assistance games, the results, the AI system you get out by solving this game, will defer to humans and will, for example, allow itself to be switched off, which is the core to the control problem for AI. And I think we should, if we figure out how to make this technology at scale, competitive in capabilities to what's already out there, then it makes sense for us to actually regulate that this is how AI systems should be built. So let me briefly talk about the large language models and how they work, right? So very simply, they're very big circuits with maybe 1 trillion parameters, and we do about 1 billion trillion random perturbations to those parameters to get them to imitate human linguistic behavior. And I know Keith said they're really complex designs. I don't think they're that complex. This is roughly how they work. So in order to imitate human linguistic behavior, they're probably going to have to start to resemble the generating process. And the generating process is us, humans, and we have goals, right? Those goals affect what we say, just like I have goals in giving this talk. People have goals in talking on Reddit and various chat rooms and all the rest. So it seems natural to question whether LLMs create internal goals to better imitate humans. Just as if we were teaching a robot soccer player to play soccer by imitating human soccer players, it's plausible that it would acquire the goal of scoring goals, because that's a good way to imitate what human soccer players are trying to do. The answer is we have no idea. I asked the authors of that Microsoft paper, do these systems learn internal goals? And Sebastian Bubeck, the first author, said, we have no idea. So we're building systems that they claim exhibit sparks of AGI. They have no idea whether or not those systems have developed their own internal goals, and they are unleashing them on hundreds of millions or billions of people. So that's another reason why the open letter asks for a pause, like, okay, you've done this much, you don't need to do the next more powerful system and remain unregulated. Okay, I think I'm going to skip over this slide in the interest of time, but basically, no matter what goals they learn from humans, it's probably a bad thing. Because we don't want them to pursue goals, we want them to understand what human goals are and help humans achieve them, but we don't want them to have those goals. Just like, humans like coffee, we don't want the machine to drink coffee. Same idea. We don't want them to pursue the goals that humans have, but to help humans, which is a different thing. And if you ask Kevin Roos in the New York Times, does GPT-4 pursue those goals, right? For 20 pages, it tried to convince Kevin to marry it, right? And you get these headlines like, creepy Microsoft Bing chatbot urges tech columnist to leave his wife, and so on, right? If you haven't read that conversation, I highly recommend reading it. So 2 more recommendations. I think to get AI systems that we do understand, that are robust and predictable, and do not present an undue safety risk, as the OECD principles require, I think we have to understand how these systems work. And at the moment, we have no idea how they work because of the way they are created. They're not even designed at all. And I believe we're going to need a different technology. I'm using the catchphrase well-founded AI systems. You can think of that as meaning AI systems whose internal principles of operation we understand and can check, just like we understand how a nuclear power plant works, we understand how the avionics on an airplane works, and we have to, otherwise people won't allow us to deploy them. We also are going to need to deal with the threat of bad actors, which Keith referred to as a reason not to regulate. I didn't quite follow that argument. But bad actors are a serious problem. How do you prevent the deployment of unsafe AI systems? We are doing a terrible job with malware, and this is going to be much worse. So I think we have to switch the way we think about permission in computing systems. Right now, everything is permitted unless we know that it's bad, right? That it matches some known signature for a bad piece of software, for a virus, then it gets rejected, we have to go to a positive permission form where nothing runs unless it's provably safe. And I think this is a very draconian standard, but I see no alternative. And it's a totally different kind of stack with machine checkable proofs and lots of other technology like that. Okay, so to summarize, I think AI has enormous potential. That potential is creating this unstoppable momentum. And we need to change the direction of that momentum towards systems that are provably beneficial to humans. And we're going to end up with a field that looks more like aviation or nuclear power than it does right now. So thank you.